In this lesson, we're going to review some of the basic types of factorings you would have learned earlier.
Hi everybody. So what we want to do to start off with is we want to go over and review some factoring. Okay? And so we're going to go through just a few little sections here where we do a whole bunch of factoring here just to help kind of get you back into the swing of things here. So we're going to start off with greatest common factoring. And remember what we mean by that. When you expand something, let's say you've got A multiplied by B plus C. Okay? We know that when we're multiplying, okay, over a sum, we have to distribute the factor. And so this becomes A multiplied by B plus A multiplied by C. Now, this is typically what you do. When you start to learn, the basic rules of algebra, this is what you learn to do. You go from the left side to the right side here. Now what we're asking you to do is to go from the right side back to the left side. I want you to look at each term and say, hey, look, I recognize this piece as being a factor here, and I recognize the A as being a factor here as well. So couldn't I just write it once out front instead of incorporated with every term? And that's really what we're trying to do here. Now, as we go through this, one little word of advice that you might take away here is when you're looking at the variable portion of this, you always want to take out the smallest exponent. Okay? So now let's just go through a bunch of examples here. Just zoom in a bit. Okay, so we're going to take a look at 12x cubed minus 3x squared. Okay, now first of all, when I look at the coefficients, between the 12 and the 3, I recognize that there is a factor of 3 that's common, okay, to both of those terms. And what that's going to leave me with is a 4 in the first term, because 3 times 4 is 12. And then I'm giving myself some room for the variables here. I don't know what's going on here. And then there's going to be a 1 left over here. Okay, close the brackets. Now, when I look at my the two terms here and consider the variable portion of it, I've got x cubed and x squared. What I want to do is I want to factor out the smallest exponent. Okay, because remember when you distribute powers and you multiply, you add exponents together. Okay, so the exponents are going to get larger. So what I want to do is I want to take out the smallest one. That's going to be the square here. So I'm going to pull that out. And when I take x squared out of x cubed, when I divide that out, okay, because remember, that's what I'm doing. I'm going backwards here, so I'm going to divide. X cubed divided by x squared is just going to be x. And then when I take it out of there, I took out the entire term. So I was just left with a 1 there. So that's it. That's the answer in factored form. Okay, 8m to the 4th minus 4m cubed plus 4. First of all, I'm going to look at the coefficients. And I can tell from 8, 4, and 4 that the common factor there is 4. But now notice that the variable m does not show up in every term here. Oh, so the m portion isn't common. So all I'm going to do is just take out that common 4 here. So 8m to the 4th divided by 4 will be 2m to the 4th. Here, 4 divided by 4 is just 1, so it's going to leave me with the variable portion. Now, here's where a mistake gets made frequently, and I could have mentioned it in the previous question, but I'm going to mention it here. 4 divided by 4 is 1. Most common mistake there is made is to make that equal to 0. Just to take it out and basically forget about that last term there, right? But because it's division, 4 divided by 4 is going to be 1. Over here, when I look at the coefficients of a squared minus a, I recognize that I don't need to worry about the coefficients. There's just 1 in both of these cases here. So, but the smallest power of the a there is going to be a to the 1, so just a. And when I take that out, I'm going to be left with a minus, we've talked about that, 1. And I can always check to see if I've done this correct by just distributing the a that I've pulled out back through and just check to see if I do in fact get the original, and I do, right? A times a is a squared, a times negative 1 is negative a. 5x squared y plus 15xy squared, okay. Well, in terms of the coefficient, I see that there is a common 5. And then between these two terms here, now I gotta look at the x's and the y's separately. Okay, here we go. Sorry about that. So we got to take a look at the x's and the y's separately here. So between x squared and x, the smallest exponent on the x is 1. And then I look at the y's. Between the y and the y squared, the smallest exponent is y. And so now, when I take 5x squared y and divide out the 5xy, the 5's will cancel, I'm left with an extra factor of x, and the y's will cancel as well. And when I say cancel, when I'm talking about division, I mean become 1. Okay? 15 divided by 5 is going to leave me with a 3. X divided by x is 1, and y squared divided by y is just going to be y. And there we go. And again, I can double check that by just multiplying through. Now, here, when I look at the coefficients, I'm getting a 6 and a 24. I know that I can factor out a common 6 here. I'm going to go one step further here. I don't typically like an expression, okay, that starts with a negative. So I'm going to take that out. And now that's going to leave me now, and there is, I don't see an x in both terms here, so that's going to leave me with an x here, x squared. And then when I divide that out, 24 divided by negative 6 is going to be negative 4. Okay? So I'm going to come back to that in a little bit here. Whoops. Okay, now with this one right here, let's take a quick look. Look at the coefficients here, 3, 9, and 6. And I recognize that there's a common factor of 3 to each of those. Then when I look at the variable portions here, okay, I see that the x is in every term, but not the y or the z, so that's good. That looks like that's the greatest common factor that I'm going to find here. Now, 3x divided by 3x is going to give me 1. 9xy divided by 3x is going to give me 3y. The x's will become 1. 6xz divided by 3x is going to be 2z. Okay, and again, if you distribute that out, you'll see that we did that correctly here. 8x squared plus 32y cubed. I look at the coefficients and I recognize that there's a common factor of 8 there. But when I look at the variables, I'm not seeing that. So that's it. That's as far as I can go here. So 8x squared divided by 8 is just going to be x squared. 32y cubed divided by 8 will simply be 4y cubed. That's as good as that's going to get. Now over here, what I would recommend people do with this one is I would make this one look pretty first. I don't like the way this one looks because what I see here is an increasing power on the variable, and I don't really like that. So I'm just going to make it look a little bit better to my mind. And I'm going to write it with decreasing power of the variable. That looks way better to me. Now, when I look at 25, 5, and 10, I know that there's a common factor of 5 to each of those numbers there. Now, but because the first term is negative, I'm going to take that negative out with it. Whatever I'm left with, whatever polynomial I'm left with, I don't want it starting with a negative. I just don't like that. I see that there's an a common to every term, and the smallest power or the smallest exponent on the a is 1. So I'm going to take out the negative 5a. So negative 25a cubed divided by negative 5a is going to be 5a squared. Because remember, when you divide the powers, you subtract exponents. So 3 minus the 1. Okay, is going to give me that 5a squared. 5a squared divided by negative 5a. Well, first of all, I was a little bit too quick with that addition sign there. So that's going to end up being negative. 5 divided by 5 is 1. A squared divided by a is going to be a. 10 divided by negative 5 is going to be negative 2. A divided by a is 1. And so that's what that's going to look like. And I think that looks better than it would have been if you had taken out the positive 5a and left it kind of in that order. And now finally for this section right here, 5, negative 10, 35. Okay, again, I recognize that there is a common 5 there. I don't mind the order that it's in, x to the fourth, x cubed, x squared. I see that the x is common to all three terms, and the smallest exponent is the 2, the square. So 5x to the fourth divided by 5x squared is going to be x squared. Negative 10x cubed divided by 5 is going to be x squared is going to be negative 2x. 35x squared divided by 5x squared is simply going to be positive 7. And there you go. That just, again, it's just a little bit of practice with common factoring. All right, now we want to take a few moments. We want to look at difference of squares factoring. Now, the way this one came about here is people would have done something like this. They would have taken a minus b and multiplied by a plus b. And when you distribute these two, you're going to get a squared plus ab minus ab plus b squared. Okay, and then we recognize that those two middle terms are just going to become 0 when you add them together. They're additive inverses of each other. Oh, sorry, and that's not plus b squared, my mistake. That's minus b squared. Okay, and then you get a squared minus b squared at the end here. All I'm asking you to do is to go from here back to this one. And it's fairly easy to do because notice I've got the a squared in here, and I've got the square root of that in front of both terms, minus b squared, and I've got the square root of that at the end of both terms, and then the operations alternate. So let's just dive in, okay? So we're starting off with x squared minus 81. As long as we recognize that the squares in both the first and second term here, this is going to become x minus 9, x plus 9. Okay, square root minus square root plus square root. Here, this is even a little bit more straightforward because I can clearly see the two squares there, so it's going to be x minus y, x plus y. Now, it doesn't really matter whether you do the negative one first or the positive one first. Just out of habit, I will tend to do the negative one first, but there's no reason for that. It's just what I do. So anyway, here, I'm not seeing a difference of squares because 3 and 12 are not perfect squares. But notice that 3 is common to both those terms. And I do see actually a is common too, but only a to the 1. Now after taking that out here, when I divide that out, I'm going to be left with a squared minus 4b squared. Now I am seeing two perfect squares there. So I can factor that down, and that's going to become a minus 2b multiplied by a plus 2b. Okay, so I might have to do a little bit of fiddling with it first before I can get that those squares to pop out nicely. Here, okay, well, I'll let you know right now, I don't like having that negative in front there. That it looks a little bit weird to me. So I'm going to make this look a little bit pretty. I'm going to factor that negative out, and that's going to change that into 9x squared minus 25. Well, I like that a lot better. And I know some people are going to say, well, I could rearrange the order here, but I like the order that it's in with the highest power first. So I like it looking like this. I just don't want the negative in front. So I'm going to take the negative out. Now I can see that this is a perfect square, difference of squares, I should say. So 3x minus 5, 3x plus 5. And I like how that looks at the end. One of the reasons why I like to make it look pretty like that is if there's ever a question I'm working in and I got to factor in a couple of different places, it's easier to see common factors if I'm just consistently writing them in the same order there. 16a squared minus 49b squared. Okay, well, it might take just a couple extra seconds here to recognize that, yep, that's a perfect square, and so is that. The square root is going to be 4a minus the square root will be 7b, and then 4a plus 7b. Okay, but you might have to think about that just for a second longer than some of the other ones we've done. 25x squared minus y squared. Okay, this one's maybe even a little bit more obvious because most of us are fairly comfortable with 25, so it's going to be 5x minus y, 5x plus y. Let's keep going. Okay, 4p squared minus 25. Again, here's another one that's like those are comfortable numbers to be working with here. So the square root will be 2p minus 5, 2p plus 5. Here, square root will be 4x minus 3, 4x plus 3. Over here, a minus 3b, a plus 3b. Okay, now we got just a few more here. Whoops. So I'm not going far enough up. Here we go. Okay, now this one might not be immediately obvious. Okay, but actually, as long as you've got an even exponent, it's a perfect square. Okay, because remember the rules are a little bit different with exponents there. Okay. If I want to take the square root of a term and it's a power, I'm just going to divide by 2. I'm going to divide the exponent by 2. So this actually becomes x squared minus y squared multiplied by x squared plus y squared. Now, before I leave here, I should notice, and this is one of the reasons why I like to do the negative one first here, is because immediately I see that I'm writing another perfect square here. So I can actually take this term one step further and make this x minus y, x plus y, but I can't do anything with the sum of squares. Okay, at least not without using imaginary numbers, and we're not going in that direction here. So that is as far as you would take this one here, and you need to, right? The whole point of a question like this is that you will take it that extra step here. For this one right here, okay, well notice there's a common, between 100 and 25, I've got a common factor of 25, and there's also a common a there. I can take that out. So I want to do that first, and that will leave me with 4b squared minus 1. Now sometimes people hesitate on this one, but remember, 1 is actually a perfect square. So this is going to be 25a multiplied by 2b minus 1, 2b plus 1. Okay? And now finally in this little section right here, x to the 4th minus 81. Now that x to the 4th, again, that is a little clue to me that I might have to look a little bit deeper in this one. But I know that the square root of x to the 4th is going to be x squared. So x squared minus 9, x squared plus 9. Okay, but now I've got this extra square here, and I take a look at this term. Okay, yeah, I've got the difference of two squares here, so I can go further. This is going to become x minus 3, x plus 3. And I don't have a rule for the sum of two squares, so I'm going to leave that as x squared plus 9. Okay, whoops, just about off the screen there, and there you go. Okay, for now in this next section here, we're going to look at trinomials of the form ax squared plus bx plus c. And in particular, we're going to look at situations where a is equal to 1. And when that's the case here, when the leading coefficient here is 1, really all we're doing is we have to look for two numbers, okay, whose product is going to be that final constant, but whose sum is going to be this middle coefficient here. Okay, now the reason why that works here, and when we break this one up here, this was broken down in x plus 4, x plus 3. Just watch what happens when you multiply these two out here. First of all, you're going to get x squared, which is right there, and that's no big surprise. But then I'm going to get, when I distribute this out, I'm going to get 3x plus 4x, and then I'm going to get 4 times 3. So this is going to be 4 times 3 is 12. Now watch, to get the 12, I multiplied these two numbers together. Now, but I'm not done with this, because what I'm going to do now is I'm going to add these two terms together to simplify it. Okay, so just so you catch what went on here, to simplify the expansion here, when I multiplied this out, to get that last 12 there, I multiplied 4 by 3. But to get this middle term, I ended up adding the 4 and the 3 together. Okay, and that's why this works here. So now, let's take a look at a handful of questions. So, I'm looking for two numbers whose product is positive 6, but whose sum is negative 5. Now, some things to note here. The product is positive, but the sum is negative. What that suggests to me is that both of these values are negative. Okay, because a negative times a negative is a positive, and when I add them together, I'm going to get a negative here. Now, what two numbers do that? Well, the two factors of 6 that I think jump immediately to mind are going to be the 2 and the 3. And when you expand that out, there you go. You're going to get negative 5 and positive 6. Here, I've got negative 15 and negative 2. Okay, well this is going to be A and A. Now, because this is negative and because this is negative here, but more so because this one's negative, I know that one of these is positive, one of them is negative. Okay, I know that has to be the case. That's the only way I get a product that's negative. And in this case here, because the middle number here is negative, when I add the positive number to the negative number, this negative number's got to be the bigger number because the positive one isn't large enough to cancel this completely out. So the two numbers that I think of that give me 15 as a product and 2 as a sum are going to be 5 and 3. And negative 5 plus 3 is going to get me negative 2. Now you should always do just a really quick mental check to see if you, when you expand this out, if you're getting this up here. Okay. Oftentimes I see students do this where they got the right numbers in there but the wrong signs. Okay. And it's just because they're not being careful. Just multiply it out really quickly in your head. Make sure that you've done it correctly here. Here, I'm going to break this thing up again. I'm looking for two numbers whose product is 30, whose sum is 11. Now, this is positive, so I know that the two numbers have to be the same sign, and because this is positive, I know that they're both positive. So this is going to be m plus and m plus. Okay? Now, 30's got a few possible factors, okay? 2 and 15, 3 and 10, but those aren't coming together to give me 11, but 5 and 6 do. Okay, so it's just a matter of, in my head, running through the possible factors of 30 that I've got. Over here, similar one. We're going to have B and B. And again, I know our product is 30, but this time it's negative 30. So I know one of these is going to be positive, one is going to be negative. Because the sum is negative, I know that the larger of the two numbers has to be the negative one. So what are my factors of 30? Where if one of them's negative, the sum is going to give me 1. And actually, in this case, it's the same as what we just did. It's going to be the 6 and the 5. Negative 6 plus 5 is going to be negative 1. 3 and 10 don't do it. 15 and 2 don't do it. Okay. X squared plus 2x is equal to minus 48 here. So again, break these apart into 2. X and X. Now, because this is negative, I know that one of them is negative, one of them's positive. But in this case, because the sum is positive, I know that the larger number here is the positive one. So now what I got to do is think about 48. Well, what are two factors of 48? Well, 24 and 2. That doesn't work. 12 and 4. Well, that doesn't work. 8 and 6. 8 and 6, and because this is, again, the positive number, I know that the bigger one's got to go here, the smaller one's got to go there. So 8, positive 8, negative 6. Well, wait a minute. I just said a few minutes ago that we're looking at expressions where 1 is the leading coefficient, and now all of a sudden I've got a 2 here. Well, that suggests to me that there's probably a common factor of 2 that I need to take out first. And when I do that, I'm going to get m squared plus 9m plus 20. Now we're going to look at factors of this one. So we're going to leave the 2 there. Now, both of those terms are positive, so this is going to be m plus, m plus. Now I'm looking for factors of 20 that add to 9. Okay, well, 2 and 10 doesn't work. 4 and 5. 4 and 5 works. A similar problem over here. I've got this 4 up front. So I'm probably going to have to take out that 4 here. That's going to leave me with x squared plus 6x, okay, we got another variable here. And then plus 9y squared. Huh. But what's interesting about this is, notice the pattern of the variables is x squared, x, no x, no y, y squared. So I don't know what the coefficients are. I haven't got a clue, but I know I'm going to have x, and it's got to be y here. X, it's got to be y. Okay? When I multiply the y's together in my last term, I'm going to get a y squared. In the middle terms, they're each going to get multiplied by an x. And then in my first term, I'm not even using the y. So yeah, that actually follows that pattern quite well here. Now I'm looking for two numbers whose product is 9, whose sum is 6. Oh, well, that's just going to be 3 and 3. And because they're both positive here, it's going to be positive 3, positive 3. So now someone's probably going to ask, well, wait a minute, can I write that as x plus 3y squared? Yes. Yes, you can. Okay, here we've got a similar situation going on with a and the b. So I know it's going to be a with a b at the end, a with a b at the end. The product is negative, so one of these is positive, one of them's negative. Because this one's negative, I know that the larger of the two is going to be the negative one. And the beautiful thing about this is 7 is prime. So the only two factors are 7 and 1. So that's got to be 7 and then 1b. And so that's it. I'm just going to back away, just leave it. It looks a little weird because I left a space there, but that's it. Those are the factors. And now finally in this little section right here, what I'm going to do is I see the 3 out front here, and again I'm going to take that out. That's going to leave me with x squared minus 7x plus 10. Break this apart into two factors, x and x. Here, the product is positive, the sum is negative, so I know they've both got to be negative, right? Because remember, when the product is positive, they're both the same sign. And so what are the factors of 10 that combine to get you 7? That's going to be 2 and 5. Okay, and there you go. Okay, so for this next section here, we're going to factor trinomials of the form, same form as what we really just did, but this time we're going to do these where a isn't equal to 1. And the method being suggested here is guess and check, and quite honestly, I think this is probably one of the faster methods you can use here. So just to show you how this works here, I've got 2x squared plus 5x plus 2, and I'm going to factor this down. I know that this is positive, so I know that the two middle terms have the same sign, and because this is also positive, they're both positive here. Now, 2, well, 2 is prime. It can only be broken down into two numbers. It's got to be 2 and 1. Okay, that has to be like that. This 2 over here is also prime, so it's got to be 2 and 1 again. Now watch this. If I guess 2 and 1, I've actually guessed something that's maybe doesn't really make much sense here, because notice that what I've got now is I've got a common factor of 2 here. But there was no common factor of 2 here. So putting the two 2's together, actually that was a bad guess. Okay, that can't possibly work here. So this has got to be 1 and 2. And now when I double check this, I mean really when I double check it, what I'm looking for here is that middle expression here. 2 times 2 is going to be, sorry, 2x times 2 is 4x. 1 times 1x is going to be 1x, and when you add those together, I do in fact get 5x, so I'm good. Here, similar sort of problem. 2x squared minus 7x plus 3. Okay, so because the product here is positive, I know that these both have the same sign. And because this is negative, I know that these are both going to be negative. 2 is a prime, so it breaks apart into 2 and 1. 3 is also a prime, so it's going to be 3 and 1. But the question is it 3 and 1 or 1 and 3? I don't know, so let's try it. If I plug 3 and 1 here, when I expand it out, 2 times negative 1 is negative 2. Negative 3 times 1 is going to be negative 3x. Okay, but those don't combine to give me negative 7, so I probably have these in the wrong order. So this is probably supposed to be the 1, and this is probably supposed to be the 3. Now, 2 times negative 3 is going to be negative 6. Negative 1 times 1 is going to be negative 1. And those do combine to get me negative 7, so that is the correct way to factor that. Okay, now let's try some more examples up here. We'll zoom in a little bit. Okay, so here we go. 2 is prime, so it's going to break apart into 2 and 2. Because this is positive and this is positive, this is going to be positive and positive. Okay, and actually we just saw this pattern, so I already know that to get, if the factor here is 6 and this is 7, I already know that this has got to be 3 and this has got to, whoops, no. I take a step back here because the signs were different back there. It doesn't work that way. And the reason why I hesitated there, everybody, is because I was about to put a 2 here, but that was going to put a common factor of 2, so that's no good. So actually, that was a bad guess. It's got to look like this. Now let's just double check that. 4 and 3. When I multiply, bear in mind, I'm multiplying here. 4, 2x times x, 2 is 4. 3x times 1 is 3. Put those together, I am getting 7x, so that works. Okay, here, I'm going to break this apart again. 5 is prime, so it's going to be 5x and x. And then the 2 here is prime. I know that they're positive and positive, so these are both going to be positive. If I put the 2 here, when I multiply this together, I'm going to get 10, and this will end up being 1, and that is not going to get me 7. So the 2's got to go here, and the 1's got to go here. 5, 2, yeah, that gets me the 7. Here, 2x, x. This is positive and this is positive, so those are both positive. Now, factors of 3 are going to be either 3 and 1 or 1 and 3. But if I go 3 and 1, when I multiply that out, I'm going to get 2 and 3 adding together to get 5. This is actually the one that I was expecting up at the front there. It's got to look more like that. So 2x times 3 is going to be 6x. 1 times x is 1x. And when I add those together, I get that 7x in the middle. Good. Okay, here, 3a and a. And again, I'm doing that because the 3 is prime. Now, this is negative. So one of these is negative. And because this is positive, the larger product is going to be the positive one here. Or so the larger factor is going to be the positive one. The thing is, because of that 3 there, I don't know which one is the large one. So let's just take a look at this. It's going to be either 2 and 1 or 1 and 2. So if it's 2 and 1, then when I multiply this out, it would be 3 together with 2. Okay, I can make that become a 1 as long as this is positive and this is negative. Okay, so 3 times 1 is 3, negative 2 times a is negative 2, and I add those together, I'm getting the 1, positive 1. So that works. The more comfortable you are with arithmetic, with just the basic, with the numbers, really everybody, the simpler this gets. So here, once again, with the 3 is a prime, so it's easy to split up. The product is negative, so one of them is negative, one of them is positive. The middle term is negative, so it's the larger one that's going to be the negative one. Okay, with 8 though, let's guess 4 and 2. How are we going to do this? If we plug 4 and 2 here, okay, 4 and 2, so let's just double check this. 3n times 2 would be 6n. 4 times n is 4n. I can combine those to get 2n as long as the 6 is the negative one and the 4 is the positive one. Okay, so yeah, twice in a row I got lucky with my first guess here, okay? And just so you know, I'm not working with the answers off to the side. I'm kind of doing this as I go here. But I am trying to kind of take it slow so that you do see kind of how I'm thinking it through here. But yeah, so those are my factors. Okay, so here's one that's finally doing it a little bit different because that first term is 12. That means there's several factors, several possible ways to do that. But the 1 isn't. There's only one way to break apart the 1, and that's 1 and 1. Because this is positive, these two have the same sign. And because this is negative, they're both negative. So now what I'm looking for here is I'm looking for really 2 factors of 12 that combine to get me 8. Okay? And actually, I can see that that's going to be 10. Actually, sorry, no, that's not true. I want to make sure that this is going to work here. Sorry, 6. I was going to do 10 and 2 there, but I need the product to be 12, not the sum here. So my 2 factors of 8 are going to be 2 factors of 12. Ay, ay, ay. See, as soon as it's at the front here, that makes it a little bit more difficult. Okay, so here's what the values have got to be if we're going to get that. This is going to have to be, well, think about your factors of 12 here. It could be 12 and 1, but that's not going to give us 8 in the center there. Or it could be 3 and 4. Ooh, 3 and 4 would give us negative 3, negative 4, negative 7, not quite. So the answer's got to be 2 and 6. And when I multiply that out, that's what's going to give me that negative 8 in the center there. Okay, this one right here. Well, the nice thing is, again, that 3 is a prime, so it's easy to break that one up. It's negative, so I know that the 2 values here have got to be different signs. And the larger one has got to be the positive one. So let's just make this 3 and 1. Now, I don't know which one of those has got to be negative because I'm not entirely sure how to break up the 6. Now, the 6 could be, let's say, 2 and 3. Now, I wouldn't guess 2 and 3. Because if I put the 3 here, then this particular factor here has 2 3s in it. I don't want that. So I suspect it could be 3 and 2. Now if I do 3 and 2, then it's going to be 3 times 3 is 9, 2 times 1 is 2. So, well, that's not going to combine to get me 17. So then I got to try 6 and 1. Okay, and again, I can't put the 6 here because that would give me a common factor of 3 here that doesn't exist in the question. So if I do it, it's got to be 6 and 1. And this is actually going to work here because 6 times 3 is going to be 18. And if I subtract that 1, that's going to give me the 17 in the middle. Okay, let's take a look at this one. Again, I've got that 3 in the back there, but this time this is positive and this is positive, so I know this is going to be 1 and 3. It's both going to be positive there. So the question is, how do I break up the 4? Is it going to be 2 and 2? Okay, or is it going to be 4 and 1 or 1 and 4 here? Now, 2 and 2, if I multiply that out, I would get 6 and 1. Well, that's not going to get me 13. But 4 can. If I break it up as 4 and 1, and I see that right away here because 4 times 3 is going to give me 12. That gets me right up against that 13, and then I just have to add that extra 1. So that's perfect. And then finally, this one right here. The nice thing is here for our last one is that we've got this 3, which is a prime. So 3 and 1. And now I'm going to break up 8 there. Now I notice that this is negative here, and this is negative, so they're two opposite signs, and the larger one's going to be negative. Oh boy, now to get to 23, well, I know, like I see the 8, I see the 3. I know that 3 times 8 is going to get me 24. Negative 24. And then I'm going to add 1 to it to get us to that negative 23. Okay, so the last 3 questions here, what you'll notice here is that middle number there, the coefficient of what we call the linear term, is kind of large compared to the other terms here. So it was a little bit easier to guess what those factors are going to be because I'm looking to try to maximize that value there to get close to that linear term. Anyway, that's the kind of factoring that we're looking at to start off this course.